Okay, you can read my introduction to the break-even point application. Let me just go ahead and do an example. Suppose a company sells calculators at a price of $45. The weekly cost for the company is $30,000 plus $25 per calculator. We want to find the break-even point. Well, to find the break-even point, we need to find where the revenue and the cost are equal. So let's find our revenue function. Since the calculators are going to sell for $45 each, our revenue would simply be 45 times x, where x is the number of calculators. Now our cost has two components. It has a fixed cost, which is $30,000, and it has a variable cost, which is $25 per calculator. So our total cost would be $30,000 plus 25x. Now both of these are linear equations. This is a linear equation that has a slope of 45, but the y-intercept is 0. This is a linear equation that has a slope of 25, and your y-intercept is $30,000. Basically, we want to find where these two graphs intersect, but to do that, all we need to do is find where revenue equals cost. This is simply a substitution problem. All we're going to do is we're going to take this cost function, and so that we can set revenue equal cost, we're going to take the value for revenue, which is 45x, and we're going to substitute it for cost. And that way we will have revenue equal cost. So if you'll notice, I've replaced cost with 45x. Now all I have to do is solve this equation. And so to do that, just subtract 25x from both sides, and I'll get 20x equals 30,000. And then if I solve that for x, I get 1,500. So it turns out that we must manufacture and sell 1,500 calculators per week to cover our cost. Now, if you want to find the actual revenue and cost, well, remember, they're both going to be equal when x is 1,500 calculators. So you can plug 1,500 into your revenue function. 45 times 1,500 is 67,500. Or you can actually plug 1,500 into your cost function and get the same value. So the break-even point is where x equals 1,500 or 67,500. This is a picture of the graph. The red graph is the cost function, and the blue graph is the revenue function. So the blue graph is r equal 45x, and the red graph is the cost function. Notice to the left of this break-even point, your revenue is below cost, so therefore you're experiencing a loss. But once you get to the right of this number, your revenue is above your cost, so therefore you're experiencing a profit. And that's why you want that break-even point, so you know where you begin to get a profit, because that's the good stuff, right? Okay, so to solve supply-demand problem, again, make sure you read the notes here on solving for what's called the equilibrium point for supply-demand. And I'm going to go straight to an example. Okay, so suppose you have a supply function given, okay, and this represents the relationship between the quantity a supplier is willing to supply with respect to the price. And then the demand function represents the quantity that the consumer is willing to demand based on the price. So to solve this, we just do a simple substitution. And what we're going to do is we're going to substitute the supply value for price into the demand value for price. So we're just going to take this value and plug it in here for price. And when we do that, we get this equation. Here's the supply value for price, and here's the demand value for price. And now we can solve this by just solving for Q, which is the quantity. So if I add 0.2 to both sides, 0.2Q actually to both sides, I get 0.27Q. And then if I subtract 0.76 from both sides, I get 3.24. So I get 0.27Q equals 3.24, then divide by 0.27, and I get Q equals 12. Now, so if we provide 12, remember Q was in thousands, so that would be 12,000 boxes of tea. Consumers will consume that amount. And of course, that's theoretically, they will consume that amount. Okay, we need to set the price for that particular consumption or supply. So we can plug the 12 into either one of these two equations. Doesn't really matter which one. I'm going to plug it into the supply equation. So when I do 0.07 times 12 plus 0.76, I get $1.60. So the equilibrium point is the quantity 12 units, which is actually 12,000 units, at a price of $1.60 per unit. So then if you view the graph here, you see that the red graph has a positive slope, so that must be the supply equation, and then the blue graph has a negative slope, so that must be the demand equation. Okay, so that's your graph of the two functions, and you'll notice they intersect at Q equals 12 and price equals $1.60. Sometimes you have to find the supply and demand equations from information given. So if you need to, pause the video and read this problem. But I'm going to tell you what you're given here. You're actually given that for the supply, you're actually given that if the price is $1.82, the supplier will supply 9,400 units. But if the price goes up, the supplier is willing to supply more. So they'll supply 9,800 units. So for our supply equation, we can use these two values to get our slope. So take $1.94 minus $1.82 over 9,800 minus 9,400, and then just plug it in your calculator, and you get 0.003. Now, P is a linear equation, so I'm going to just say P equals mx plus b, and I'm going to use x this time for quantity instead of q. Sometimes you can use x or q. Alright, so I'm going to plug in one of my points here. So I decided to plug in the second point, 9,800 and $1.94. Now when I plug that in, I get $1.94 equals 0.003 times, let's see, did I plug in the wrong value here? Yes, it looks like I did. Let me correct that. Okay, it looks like I did the calculation with the right value, but I just wrote down the wrong thing here. So 0.0003 times 9,800 is 2.94, and I have 1.94 over here, and then when I subtract 2.94 from 1.94, I get b equals -1. So now that I have b, I can say the supply equation is P equals 0.0003x minus 1. Now, you can actually do the same thing over here. If you notice, if you read the problem, you'll see that the demand is at a price of $1.82, the demand's 9,500, but when the price goes up to $1.94, the demand drops to 9,300. So you can go through the same process here, find the slope, -0.0006, and then plug in a point here, and I plugged in this point, $1.94 for price and 9,300 for x, and then I solved that for b, and when I got b equals 7.52, and then that gave me the demand equation. And so here's the demand equation, P equals -0.0006x plus 7.52. And I'll leave it to you to set these two equal to one another and find the equilibrium point and show that the equilibrium point is at a price of $1.84 and roughly 9,467, if you round it, would be the quantity. 9,467, if you round to the nearest whole number, is the quantity. Okay, the final method is the elimination method, and again you can read the instructions and I'll just do the examples. Sometimes they're very easy, like these two equations are very easy to solve. You just add them together and the y's will eliminate. So here if I add these two together, x plus x is 2x, the y's cancel, 3 plus -1 is 2, and then you solve the equation 2x equals 2, which gives me x equal 1. And then again you can take that 1 and plug it back into either of these equations. So I plugged it into the first one and I got 1 minus y equals 3, and then that gave me that minus y equals 2 or y equals -2. So the answer is 1, -2. You may have to multiply one of these equations by a constant. Here I saw that the first the coefficient of x here was 2, so if I could make the coefficient of this x -2, then I could add these together and eliminate the x's. So I'm going to multiply the second equation. I'm going to multiply everything by -2. Now that doesn't change the answer, that just changes the equation, but the answer is still going to be the same. So -2 times everything here is going to give me the equation, second equation is going to become -2x minus 6y equals -18. And then when I add these together, the x's cancel, and then I get y plus -6y is -5y, and then on the right 8 plus -18 is -10, and then when you solve, divide by -5, you get y equals 2. And then you take the y equal 2, plug it back into either one of these equations and solve for x. I plugged it back in the first equation, so I got 2x plus 2 equals 8, so that would be equate to 2x equals 6 or x equals 3. So the solution here is 3, 2. Sometimes you have to multiply both equations by a constant. Here I had to multiply this equation by 2 and this equation by -3 so that the x's would be opposites. And when I did that, I got 6x minus 4y equals 16. And then the second equation became minus 6x minus 15y equals 3. And then when I added them together, the x's canceled. The y's added up to -19y. The constants added up to 19. I divided both sides by -19 and I got y equals -1, and then I took the y equal -1, plugged it into one of these equations. I plugged it into the first equation, I solved it for x, and I got x equals 2. So the solution is x equal 2 and y equal -1. Now you could have eliminated the y's here if you wanted to. You would have had to multiply this equation by maybe 5 and this equation by -2, but you could have done it by eliminating the y's probably just as easy as we did by eliminating the x's. Okay, I'm going to finish up with an application problem, and then you can read the rest. There's a couple of other problems you can read, plus a couple of application problems that are set up. But pause the video and read this, and let me just go to the setup here. Basically, you have x equals the number of ounces of milk, y is the number of ounces of juice, and then over here is how much you need, how much calcium and how much vitamin A you need. So since you get 37 units of calcium from milk and 5 units from the juice, then we know that 37x plus 5y must equal 500, so that's one equation. And then you get 57 units of vitamin A from the milk, 65 units from the juice, so that has to equal 1200 for the vitamin A. And so that's how you set up the equation. And you'll notice here I had to multiply the first equation by -13 so that I could eliminate the y's. And then when I eliminated the y's by adding them together, I was able to solve for x. And so I got x equals 12.5 ounces. And then I took that x value and plugged it back into the first equation and solved for y. And I got y equals 7.5 ounces. So it takes 12.5 ounces of milk and 7.5 ounces of juice to satisfy the conditions that it's asked for in this problem. Read the rest, and that'll do it. Bye-bye.